Are you going? Is it going? Oh, it is. Okay. So, hi, I'm Nelson.
And I'm Sid, and this is Hacking Electronics Part 1.
Yeah. So today we're going to teach you about the very basics of circuits and how to hack hardware using the Arduino. So the Arduino is a very useful board that you could buy from me if you want one. And what it does is it allows you to control circuits that you've built just by switching voltages on and off. So we'll teach you about these basic concepts right now. So the best way to think about circuits is using the water circuit analogy. So let's talk about the very, very fundamentals first. So the flow of electricity is caused by a buildup of charge. Charge is just one of those fundamental, basic physical quantities that exist in the universe, and it's usually carried by electrons. So you all know about the classic example: you rub your finger against the carpet, or you rub a balloon against your hair, and it builds up charge, and you have static electricity. So when you touch something else, you see like a little spark, and it might hurt, and you see like the electrons will be jumping across from your finger to whatever you touch, and that's basically just because you have a lot of electrons or charge on one side and less of it on the other. And it's just as if you had a lot of water built up in a tank and there's a lot of pressure and you just had an outlet for it to go through and just like shoot through.
Yeah, and so this introduces our analogy of thinking of three main concepts very important concepts of circuits, and that is resistances, currents, and voltages. So in our analogy, you can imagine a voltage as like building up pressure for water, if we're considering water as like our electrons or our charge. So when you have a lot of voltage, that means you have the ability to push your water, very hard, how fast, whatever. And so as a result, current becomes like the flow of water, the movement of the water through your like pipes, or in our case the circuit, will be considered, we'll call that current. And finally, resistances, as you can see there's like a resistor right here. Resistances are basically when you constrict, you want to, it resists the flow of the water, so that would be like the pipe being constricted or being made more narrow, and as a result, you'd require more voltage or pressure to push the water through.
So yeah, this is a very convenient analogy and a way to think about circuits, about how charge flows through the circuit. So like Sid said, the three main quantities that will hammer into your heads. Voltage is like water pressure, it's what causes things to get pushed through the circuit. And current is basically just the amount of water or charge that's getting pushed through a certain space in a certain amount of time. So in resistance is like the tightness of the pipe. If you're talking about the circuit as a pipe, it's how hard it is for that water or for that charge to get pushed through. So if your pipe is tighter, if you have more resistance, in order to get the same amount of charge to flow through, you have to push harder, so you need more voltage. So this brings us to the fundamental law that anyone will learn in their first EE class, and this is Ohm's law. So just write this on the board.
So Ohm's law is commonly written as V equals IR, or voltage is equal to current times resistance. In our water analogy, this would be analogous to saying that the pressure, how hard you need to push the water through, is equivalent to how fast you want the water to move multiplied by how tight your pipes are. So this formula is used for many things. When you're making your circuits, you want to make sure you have enough voltage to push through all your resistance. If you have too much of an R and your V is not high enough, your I is basically going to be very little, and you're going to have very little current. And so current is the main thing that drives your electronics. So when you have a light bulb, for example, so if I draw a light bulb here, so inside the light bulb, there's a wire, and when current flows through the wire, the fact that the current flowing through the wire is what makes it glow. If the current gets smaller and smaller, the light bulb gets dimmer. And so as a result, in our equation, V equals IR, if you need a very high voltage in order for the I to be high as well, if you're depending upon how your R is. So the basic thing you just need to know is that if your R goes up and your voltage stays the same, then I, of course, goes down. And vice versa. If I decrease my resistance, then I'll have more current because the water will be able to flow through in our analogy. And so, just as a simple example of drawing a circuit, generally voltages are produced by batteries and things, and there can be other sources as well. So when you draw a voltage source in a circuit diagram, it generally looks something like this for a battery, or like this. And of course, this also brings us to our concept of polarity, which is like these pluses and minuses. And so This is something that you always see in circuit diagrams, but you might have never really known what it meant, and that is because voltages, this V, is actually not an absolute quantity. Well, what do I mean by that? It means that when I go out and I like point at something in the world and I ask, what's the voltage of that? That actually doesn't necessarily mean anything. Voltages are always a difference between two basically energies, because a voltage is like a potential energy. So when you draw a battery, you have a plus and a minus, the voltage of this battery is actually like the energy at one point of the battery, one terminal, and it has another energy at the bottom terminal, and so the difference between those energies, that is what the voltage is, okay? And so generally, when we refer to this minus sign, in all circuits, we generally usually refer to something called ground, and ground is drawn by this symbol. Okay, and all ground represents is basically like our reference voltage. In other words, this ground is where we call a like zero voltage. So anytime so for example, if this battery, if on a circuit diagram you see something like 5 volts, all this means is that at the top of this battery, I have 5 more volts than at the bottom of this battery, which is where I have ground. So once again, all voltages is a difference in energy. And the moment I have this difference in energy, all this battery does is it puts all my electrons, all my charge, all my water at a very high energy state, or in the water analogy, a high pressure. And that gives us a good starting point for it to flow through the circuit, and then as it flows down the circuit, all that energy slowly gets used up, and that's how we use our electronics.